Hello there. So this particular circuit is, you've already done the circuit like this before. This is our circuit, which is, we see here we have a CD4017. That looks familiar. That we know that is a decade counter. And if we, I have to pull it out because this one's so small it doesn't have a full size bag with like an instructions. Over here, if we get our zoom in, there we see we have an NE555. So we can see this circuit has CD4017, this is a decade counter. And over here, we have NE555, and this is a 555 timer. And if we count these over here LED lights, we're going to get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this circuit is the same as this other circuit that we previously had. This is a decade counter circuit. So the lights are going to be flashing. But this over here, this circuit is, as you see here, we have holes, and it goes through the circuit board, and we soldered to the underneath. This over here is a different type of circuit. This over here has individual components that are called surface mount components. Now there's still things like, if we look at the LEDs, let me get one of these out. Our LED lights are still in our traditional form, where they're going to go through these individual holes here, like that. Right, so they're going to be what we would consider like normal, what we've previously done. They're obviously smaller. But other components, such as this is where our resistors will go. That's our resistor, like our resistor 1. It will go here. We see there is no hole for that resistor to go there. So we've got to say, well, what is our resistor then? These are our resistors. They are literally these tiny little things here. Now let me get something so we can actually get a size comparison. So we can actually see how small these resistors are. What is this? Can't believe the smallest. Okay, there we go. So, unfortunately, I don't have a 5-cent coin on me, but I do have a 10-cent, a $1 coin. So we can still see these resistors are actually very, very small. If we look over here, they're about the width of my pacer. They're double the. Oh, let's get that shine off, please. Hold on, let me see. Unfortunately, they're on a white background, but we see here they are still quite small. And so we're going to have to be very careful when we solder these, and we have to obviously find a new approach. Over here we have our smaller versions of the decade counter themselves. So as we see here, it's the chips are slightly different. They don't have little feet to go through holes. We're going to have to solder them directly onto the circuit board. So we're going to have to do an additional type of soldering. So before we do any of these activities, the first thing we're going to do is we're going to do our stock take. It's going to be a bit more difficult than previously, because once we deal with smaller components, the stock taking itself is actually more of a challenge. So to start off, LEDs. Alright, let's just get the easiest parts first. We have our stock take over here in the corner. Let me enlarge that for you. Alright, so LED. I'm going to say item 1. We're going to say LED. Our value is, these are 3mm thick LEDs. They're smaller. So they're smaller than the ones we've had before. 3mm. Their codes, they haven't given us codes on this particular board, but so we don't have to worry about their codes. But we know those are our LEDs, and we should count them. Let's make a new column. Insert. Count number. And I believe, if I have them all here, correct. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have exactly 10. We have exactly 10 of these LEDs, and they go over there. Cool. Then let's have a look at what component do we do this? Okay, so these are resistors. Oh, are we actually able to see that? Do you have enough zoom? Let me see if I can do it on the big camera. Does it have the focus for it, or am I not gonna? Oh, there we go. So we see there, the resistor has a number written on it. So let me read out to you what the number is. The number says 102 on the resistor. So what that means, let's see if we can get one of these out now. How am I going to? For this experiment, I just want to get a single one of these out. And so they come in these trays, because obviously when you have something this small, you can't just put into a bag. So they come in this strip. They come into this strip like with holes on the bottom. And then there's like a layer of like protective tape at the top, so their pieces don't fall out. So if we just remove the tape, alright, oh, and there we go, that tiny, look at actually how small that resistor is. That is absolutely amazing. So I'm going to get my voltmeter now. Bear with me please with this one. I'm probably not going to be able to carry up the voltmeter to the top. So you're just going to have to take my word for it on this one. So I think that I'm touching. Is there any way I'm going to be able to touch both sides? Alright. I think if I do it this way, I think I am actually touching. I think that's actually touching both sides. Let's see if we can get it. Oops, I lost it. Nope. Okay, let's try again. Alright, so it has picked it up as a resistor. It's upside down, but 1000. Alright, so we see that we have the number 104 on the resistor. So what this is saying is the resistor, 10 being 10, and sorry, 102 it says on it. So 10 being 10, and the 2 is how many zeros? So it's adding 2 zeros onto it. So it's 1000, which is 1000. So that's how I read this. And later we'll have other resistors that are slightly different. Now, I have to be super careful with this because just breathing can sometimes put it in the wrong location. So it's the hardest part of this kit. Let's just put that to the side there. And I counted 1, 2, 3. I count 11. So it looks like they've given us one extra one, which is, when it comes to these resistors, I'm actually very happy that they give us one spare one, because these things can, like, they can just go. They're very, very easy to. They're very easy to be lost or dropped. Yeah, and it's annoying that it's on a white thing as well, so it's hard to fully see it. Actually, I'm going to drop this one on the circuit so we can actually have a look at it. Boop. There we go. So you see how tiny that little component is. And that was so item number 2, and there were 10 LEDs. There were 11. How did we do it last time? We went so we need 10 because I counted on the circuit already, but we come with 11. And oh, what is the item? It is a it is a resistor, and its value is 1K, and its code, it looks like it's R1 to R12. That doesn't make sense. Where are the other resistors? Oh, there's other resistors on the side. Okay, so we can't just say R1 to R12. We can say it is resistor. It looks like everything except for resistor 2 and 3. So the code for this. Why is this? This is being annoying. Okay. So the code seems to be 1 and then 3 to 12. R. Okay. Cool. Follow along? Great. Okay. Next components we have another one over here. And this part over here has written on it 103. So using the same approach we had before, we only need one of them, and we know it's a resistor. And 103, so that would be 10, and 3 zeros, that would be our 10K. And if we look at our circuit diagram, our 10K relates to, where is our 10K? Where? Our 10K is this one over here. So 10K is our R3. Oh, hold on. Oh, that's annoying. Was there R4 missing? Oh, R4 is over here. So it is not 3 to 2, it is 5. 5, because it's over here. This is R3. And then now number 4 will be, there's another resistor that I'm going to pre-write it down. If we look at this over here, this over here says 202. So that would be 220 and 2 zeros. So that would be our 20K. No, 2K. 2 zeros. And that is our, on our circuit, that's this one over here. So that's our R2. Great. And I believe that's all our resistors. Next we have these two components over here. These are capacitors. Now, unfortunately, like sometimes you could have the same thing where the capacitor could have the writing on it like the resistors. These particular ones don't actually have a value written on them. So, I mean, looking at our chart over here, we see that there are two slots for capacitors. We see there's a slot for capacitors up here, right? And a slot for capacitors over here, and they're both 1 microfarads, so they should be fine. But I have access to a voltmeter, so let's see if I can do the same thing I did with the resistor, just to double check. Just to double check that we have the right component. So let me just get this over here. Alright, if we plug it into the calculator, in the thing, right, we get 950 nanofarads. So that's 1/1000th of a microfarads. So that's close enough within the percentage of like 1 microfarads. So it's 1,000 N's is a U. If that's somehow easy to think about, but so we got this, and again, it's can't be 100% accurate. It's probably slightly adjusted by, well, it's nothing. It's very difficult to get very high accuracy of these components, and it doesn't actually matter when we have another thing in there. All right, so we've got to not lose that. So, where were we? 5. We have. We actually need both of these. So and these are caps. These look like they don't have a positive or negative side, so these would be ceramic capacitors. And their value is 1 UF, and its location is C1 and C2. C1 and 2. Then what are we left with? We are left with this component, which is our variable resistor, which has 503. So it's using the same terminology as our resistors, where 503 means 50 and then 3 zeros. So that would be 50K, right? And so it relates to this particular part over here, So this is, and that's a potentiometer, is its technical term. So we have one of that, and we have a pot, short for potentiometer, 50K, and it is R4. Then we have 7, 8. The last one is our circuit board, printer circuit board, so we don't have to worry about that. So these two components, right, we've dealt with these before. This over here, the vision for this is going to be real difficult to get up. Oh, there we go. It's upside down. Oh, of course it is. uh, Come on. It doesn't like it. What about the smaller camera? Let's try that again. Maybe if I take the glare off. I think when it comes to these small components, we have hit the limits of my $5 camera from the internet. Oh wow, never mind. Alright, so we got this over here, NE555. Oh, that's actually a brilliant zoom. Oh, NE555. While we're at it, let's see if we can see the, there we see the resistor over there, there we see the 102. That's actually a really, really good zoom. Let me see if I can get something to elevate all my work up to that height. So I can just remember. Oh no. Oh no, it's not. Hey, there we go. So we see there we have NE555. So we've dealt with this before. This is our 555 timer. So so this is 555 NE555. Actually no, its count is 1. It's a IC, and that's a 555 NE555. Does it have a U? It's on the circuit board U1, which is over here. Then let's look at the other one. Do I even have to take this one out? Or can we see it? No, so it is the glare. Ah! Oh no. Well, there we go. There's our CD 407, 4017. IC 1, and this is going to be our U2. The last part we have is just these random connectors. So 1, connecto. Alright, so how do we actually go about soldering this? So these larger components, I'm actually going to keep these for later. I'm going to put these down onto my board. And I'm actually going to, so the order is I'm going to always do all your surface mount components first, and you actually do the hardest component first. So when it comes to dealing with a typical resistor or something, we would always get it and we would fit it through, we'll put its holes or something through the sockets, and then we would just solder it on. The problem we have here is there is no holes for us to stick stuff through. So we want this resistor, we want it to essentially be soldered into this situation like that. Right, we want it to be soldered onto the individual component, sorry, onto the where the two metal pads are, to do it onto our circuit. So I always, well, we have our normal hot soldering irons where the piece of metal gets hot. In the ideal world, in like the mass manufacturing world, you'd actually use a hot air soldering iron for this, where you'd put a piece of like a piece of glue, a solder glue, onto those joints, and then as you heat up with the hot air, it would melt the joint together. We don't have that. We only have the classic soldering iron, and as you see, its size is not ideal. Its size is like larger than the entire thing. So this is an activity where if you have adjustable solder tips, you get the largest. So you get the what's it called? You get the smallest element on the end, because you're going to want to be as precise as possible. And usually when I solder with the whole roll, but for this particular for these particular experiments, I'm going to cut my long piece of solder, so I'm dealing with a small length of solder. So let me show you a problem. When you go to solder this circuit, right, if you just solder the piece normally, right, so you get some heat, it's actually going to lift up. So let's say we put the heat on that component there, and we see how it lifts up. The piece is like not connected anymore, and how it disconnects. No, don't break. It wants to stick to a piece of metal, so this is not ideal. What we can do is, firstly, let's get that component. You're probably going to need something to help you, like a set of tweezers for this activity, because you're dealing with small components and you can't put your fingers near there. There's physically not enough areas for you to hold on to. So let's just put that aside. Let's just put this thing aside for now. So let's start by first putting up, let's just getting solder onto these joints. Alright, cool, that's enough solder just onto these. So these joints now have solder on them. Now we're going to get our individual resistor, and we're going to heat the resistor and the what we're going to try to do is we're going to try to heat up. We're going to try to solder our resistor to one of the parts, but then hold it down with a tweezer. If you don't have a tweezer or anything, you can also use a pen or a pencil, a toothpick, something. Obviously, if it's wood-based, be careful because we don't want it to burn. But you just want something to hold it down so it doesn't like get lifted up by the forces of the solder. So we see that one soldered down. That looks good. And so now when we have our other part, we just heat that up and make sure it's connected. Now I believe this part over here, that is a surface mount part. Done. It doesn't look pretty, I'm not going to lie, but we can test if this part is working. I'm going to try to touch the circuit. Yeah, I've got the 1000 resistance, so that seems to be working. Sometimes it's going to be difficult for you to putting solder on both sides. The other alternative is, depending on how your soldering iron is set up and how your skill level, you just try putting solder on one length. So, and focus on soldering one part of the component down, and you're going to allow that, when that cools, when that individual part cools, it is going to, oh boy, difficult taking the, just trying to take the tape off for this particular part. You would have thought that the tape would be the most difficult part to get off. So let's try that again. So we have a tiny resistor over here. Right? Why do you, oh, there we go. So we have this tiny little 102 resistor over here. Tiny little 102 resistor. Let's try the other. Let's try putting solder just on one side of our component. Go away. Okay. Can you see what I'm doing? Don't want to lose you, but I want you to be on camera. All right. So we're just going to put solder just on one paddle over here. Cool. All right. Now let's get our 102 piece. Now let's try doing it without a. Let's say you don't have a tweezers and you have to use like a. You have to use something like a pen. So for this particular case, we're just going to align this up as close as we can. Right. So now it's like right next to it, and let's hold down with this pen. All right. So hopefully that picked up on camera, but I'll give it another example. So you see there, I held it down enough so I actually pushed this, and it's actually locked in place due to this original piece of solder. So that's how we control. That's how we control these small pieces on. And I believe that second case looks. I believe that second case looks better. And you keep using one side and the other to get a better soldering. There we go. That's almost perfect. So let's open up the whole tape now, and let's go through all of them, and so I can get the best ones for make a video. Oh no. Well, I have lost a whole bunch of these. Because I be really careful with not losing these. So make sure you open them on like a tray or something. Let me just do a count. Okay. Oh my gosh. You can see why they give you extra ones of these. So we need 1, 2, 3, 4, 5, 6, 7, 8, and we have 1, 2, 3, 4, 5, 6, 7. So I've got to they're falling down here. Good, good, good. 8 and 9. So with these, please take your time with these. I would only take out the parts that you actually are using, because as you can see, they're very, very easy to lose. Your other option is you can get like a piece of sticky tape and like have it on your bed, as in not your bed, as in your table that you're working on, and so the components are on the tape, so they won't go flying around. In fact, I might try that. see how that works. You just want something so these components don't go walkabout on you. Because like if you can imagine, if these get put on the floor, there is no chance of you finding these components. So this is like what I have here. They're all on a piece of tape. I'm going to have this to the side over here. So let's take off a component. Let me try. I'm going to try to do this one without any tweezers at all, just to show you how to do it. So, all right. So we have this over here, and we're going to solder this part onto there. Let me try to get that right on the screen for you. There you go. So we're going to solder this component into there. We are going to first put solder over here. Oh, by the way, I am at 350 degrees right now. If you have an adjustable soldering iron, just so you know what temperature we're working at. Right, then we're going to get some sort of a stick or poking apparatus. We just want to hold this resistor down. So right now I'm pushing it as close as I can. I'm pushing it next to the solder, and I'm holding it down. So now when we heat it up, there you go. That should be locked in. Now let's get the there we go. Ah, I missed it. I moved it. I'm sorry. I'll do it again with the other one. With this, don't have to worry about being as neat. Like, just worry that it works. Preference it just working. Yay. You do want to solder them. You do want to solder them the correct way up. Where'd you go? Okay, I've just lost one. Oops. Ah, where were we? This new angle, let me just... Okay. So the first thing we're going to do is we're going to put some solder. I'm going to clean my soldering iron first. Let's add some solder to the circuit. Gonna hold it down. A little bit of heat, and now it's locked into place. And now I will not move the part so it doesn't leave your field of view. There we go. That's probably my best one so far. Let me zoom that one in. See the job? So now we just continue doing that throughout the whole circuit. going to save myself some time. I'm going to pre-solder now the first. And you notice when you're hitting the solder, it wants to attach to the soldering iron, right? You don't want spiky parts right next to where your components are going to go, because it's going to force them to like lift up and not act how you want it to act. So use your iron to like drag like your components away. So drag like the sharp peak of the solder away from, drag it away from the where the component's going to be, because we want that to be as flat as possible. We want to like slide this component on top. I found you. Let me see. I don't know if you. I don't think you can do it without a. I wouldn't recommend doing it without a. Like obviously, tweezers are good, but I've found the tip of a mechanical pencil works quite well. Also, because it's graphite, so if it does, the problem is if you use a piece of metal, like a wire or something like that, you run the risk of that component actually getting soldered to your part, and then that being difficult to desolder. So ideally, you want to pick something that's not going to get not going to get attached. It's not going to get soldered to your individual parts. So, like graphite is good because the graphite will easily break off. So that's why graphite is good. Like a tweezer, not a metal tweezer, if it has like a coating on it, would work. A toothpick would be great. We just gotta make sure that it doesn't catch on fire. So we might need a few toothpicks. Don't pick anything plastic, because plastic will melt. Okay, the difference between the toothpick will singe and burn, but it's not going to melt and like attach to, because the worst thing we want is the plastic to melt all over our components, and then it covers up like these lovely sealed locations, like these exposed metals. That's going to cause larger problems. Because you're dealing with low light situation here as well, so we want to make sure. Sorry, not low light. We're zoomed in, we're very far in, so we want to make sure we have good visual. We want to make sure we have good visual representation as well. Not visual representation. We want to have good light source. As in, you don't always have to hold it down with the pen. You're just going to use it as it's melted. That like fraction of the second you have as it's melting. You're going to use the pen just to guide yourself around as it's melting. I love it. All my friends are like, "What did you do during your quarantine or corona social isolation?" Me, I made circuits because I'm so cool. So right now, all the resistors, this first round of resistors done. Now, prettiness, you can obviously rate them based on their prettiness, but we care more about functionality. Like if you wanted it to be neat and perfectly aligned, you would have used a hot air soldering iron. We don't. It's because we're using a soldering iron, an iron instead of like a hot air blower. We're just worried about it being functional, and these all look functional. We want to ensure that. Over here we have an example of the resistor, the underside of the resistor. We see, right, when we have a look at a resistor, we see that it has these two exposed metal parts. We want to make sure those two parts overlap. Let's say this part over here is an example. We want to make sure those two metal parts overlap the two metal surfaces, and that there's a solder that's gluing those all together. That is the main important part. Now this over here is a spare one. I'm just going to take this tape away. I found the tape to be unnecessary for my particular setup, but you might need the tape on yours. So let's finish off the other resistors. We know we have a 12K resistor somewhere. Sorry, 20K. This over here looks like the 20K resistor. Let me just... Obviously, if you're using any sort of knife, make sure that you are very safe with it. In fact, depending on how old you are and how responsible, get an adult to help you with the knife with regards to cutting components out of their containers. And if you don't have a responsible adult, you're going to have to use your fingernails. Ooh, lucky. Lucky that jumped over to there. I only need one of these, so I'm going to keep the other one in the container, so in case I lose this, I can easily just get the other one out. Oh, I thought I lost it. Okay. So this over here, just to confirm, it is a... Oh my... It is a 20K resistor. Flip. Tony Hawk over here. Come on. There we go. 202. So that means it is a... 202 means it is 20 and 2 zeros, so that is 2000. That's our 2K. Let's load up this thing. This particular one I'm soldering the other way around just so I can show you from like a different camera angle. Okay. Let's get this 202. Now we have that lined up. Let's hold this down. There you go. Sometimes you're lucky and it's not going to want to lift up. But we have the pen there just in case, because we have to melt the solder, and then as we're melting the solder, if it does lift up, we have to move it with our pen to lock it down in place. But so that's there. That's the 202. So the 20, yeah, the 202, which is the 22K, and then let's just finish that off there with a bit of a solder. Let me see now. Let's get some extra light because our stream has slightly changed. Cool. Next we have our 10K. I found in that case, it didn't actually want to lift up, but as I was moving the solder away when it's liquid, as I'm moving the soldering iron, the solder wants to attach to the soldering iron, so because the part weighs so little, it wants to move with it, and so you could also use the pen in there just to lock the component in place. I think that's good enough. Okay. Our capacitor is done exactly the same. What I will point out with our capacitors, see how they have this yellowish color? Right? In all circuits, that they try to leave the colors of them constant. So if you see a part that's like this yellowish color, that's usually a capacitor. Now also the capacitor is a lot thicker than the resistor, so it's going to want to really get absorbed by the solder. So we have to be super careful with this one, and that be vigilant with your pen as we put that in. So again, we're going to load up for this one. I will load up this side, I guess. Right, we have a ball of solder on there. I'm just going to arrange this to come over here. Yeah, this one's very, because it's more how to describe it? It's more 3D, and it's going to really want to get absorbed by this. Let me get a good angle for this one. See, I might do it this way. There we go. Oh, that is perfect. I am like the solder king. There we go. Cool. So that's our piece of our capacitor. If we overload, we put too much solder in the circuit, it will like jump, make a short circuit, but I don't think that's going to actually affect us. So this situation looks fine as it is. We see that the solder went all the way up to the top, so it's really ready to be absorbed by that. Our other capacitor, nor did they didn't give us any spare capacitors. They said, nah, you're good fam. You don't need any spare capacitors. What they're saying is they believe in you, right? They're not stingy. They believe in your ability to solder, so that's why they're only giving you one. They're not giving you any chances. It's like, oh, thanks, bro. Thank you for believing in my solder abilities. Unfortunately, I can't have it angled that way because I'm right-handed. Sorry, but the board is now angled, so. The one good thing about not having a number or any numerical representation on this is it doesn't actually matter which way you solder it. So notice here how the soldering iron's moving. That was an example that I was saying how if you don't have the pen or something to catch it, you're not going to be able to stop the component's going to be stuck on the soldering iron. So yeah, it's going to be stuck on the soldering iron. So that's what we're using the pen for, or the whatever device you're using. Okay, so that looks like that's all the surface mount, or the passive surface mount components. We have our capacitors, our resistors, they're all on. Good. So now let's get to the juicy stuff. Alright, we have our chip. We look and we see an icon. We see over here we have this little dot. Let me put my soldering iron away for a second. Can we get some light extra? Ooh, real bright light, like it. Okay. So we see here there is a dot on the circuit. Let me see if I angle it, is it better? We see that little dot right there. pointing at. So this dot over here represents this dot over here on the circuit diagram. It also represents that this side, we have that little divot over here. So that's how we can know how to line up. The circuit diagram lines up this way. It does not line up that way. Right? So it's obviously a lot harder with our smaller components. In the same sense as before, when we soldered, it's going to want to move and follow the soldering line. So how we do this is, again, we're going to preload up solder on our first line. All right, so let's just pick a corner. I'm going to pick this particular corner over here. All right, we're going to get pre-solder over here. Then we're going to get this part over here, make sure it's the right line. Depending on your part here, you might be able to use your fingers, but I would recommend against that. I would still recommend using some sort of tweezer or other component. Let me get you a better angle on that. Right, so we're soldering this part over here. Let me just clean my soldering line. Alright. And we are trying to hold it down and make it not move. Oh no. Right, I think that's good. And we see this is I can move it and it's locked in place. So now as I solder all the other legs, I like to, once I've done this pin over here, if we want to call this pin 1, right, I want to do the pin that's furthest away from it as my next solder joint, just so it like spreads the load, and it also lets the heat dissipate to make sure that I'm not putting a lot of heat in the same part of the circuit a lot if you're soldering the circuit constantly. So just spreading it out over here. There you go. And we just soldered that part, and then just start picking components that are like far away. So I might pick this part over here. Still some solder left on my soldering iron. Just go through this, take your time, constantly clean your soldering iron. Right, this is not an activity that you can rush, this one. Oh no. You are gone. There you go. I believe that is an entire IC chip. Now that that's the entire thing done, again, it's not going to be the prettiest. It's not going to be the prettiest component that we have, but it is definitely secured. I'm inspecting it with obviously your eyes, but if you have like a magnifying glass or a very high-res camera, you can look in that as well. You just want to make sure all the parts are connected. And let's do the same thing with, so let's do it again. If we look at this over here is our IC CD4017, which is this chip over here. We look for where the indicator mark is. We see that it's this part over here. There's a little indicator mark. We look at there's an indicator mark on the circuit diagram, so we can see they would line up in this way over here. And then we're going to do the same approach, where we're going to put solder onto one of the planes first, onto one of the components first. All right. There is our. Let's put a bit more. So we have solder on that first component. Now, I don't know if it's that much. Let me see if I can show you an angle so you can see it's not a large amount of solder, and it's less than we put for the resistors. So we have the piece of solder there. We're going to get our component over here. I like to, if you can, like if you can find a way to balance it, balance your component so it's actually on top of the solder, and then we're going to use our pen to we're going to use our pen to align it. Just have our pen ready as we heat up. This one's a larger piece, that's slightly annoying. Alright, let's just get ready with our pen here. Alright, we're on. Oh, there we go. Not aligned, but in fact, actually, the problem I had is the actual circuit board, because I'm up close to the camera, I'm not able to have it on like a nice solid background. So what I'm actually doing is, you can see on my other camera, is I'm just taping it. Let's see here. I want to see if I can align this better. So now, when I'm going to heat you up. There we go. That's a lot better. Alright. And let's just do the other side to secure it. And then, if you're fast and once you get more skilled at it, once you do the two corners, the actual order for the rest of them doesn't matter. As long as you're fast enough that that heating's not a concern. Over here we have these two corners are done, and so now we can just run through them fairly quick. We do want to make sure that we feed the solder in a way where we know it's not touching. Oop, like we just did there. So we're going to need to get the solder sucker to fix that. Alright, solder sucker. Solder sucker, we've already used those before. We press the plunger down. We're going to heat it up. We're just going to extract solder from this area. Did you get any of it? I think it did. There we go. Cool. Fixed it. Solder sucking is fine for these larger components, but it's going to be very difficult to solder sucker where these resistors are, for example. So we just got to be careful with that. We might have to find another way to. Oh, you can solder sucker. We've just got to be very, very careful because we've got to hold it down. You might need an assistance of an extra person to get the extra. So, if, for example, you hold down the resistor with your pen and you melt it, and then you get somebody else to activate the solder sucker. You will make mistakes with your IC. I have two solder sucking scenarios over there. It's just because you're working with components that are actually so close together. Sometimes, although, you heat it up and they'll fix themselves. Nice. There you go. Cool. Now we have the easy part. This is the fun part now. And yes, this is our resistor, our LED lights. We use the same approach. Unfortunately, this particular kit didn't come with any this particular kit didn't come with any surface mount LEDs. Now that's when you start to deal with the real interesting stuff. Now, interesting. We notice how these surface mount components, they all have the exposed elements all on this top side where the numbers are. But for the through-hole components, if we look, they actually have it exposed on both sides. So it allows you to really solder your LEDs. You can solder it on the underside, just like I did there with the switch. I didn't even realize I swapped those over. But investigate your circuit to see if it, like this, has everything in that location where you can actually solder on the underneath, because again, you can only solder where there's an exposed. You can only solder where there's exposed material. Ooh, not my best job on that one. This is not a great. Let's see if I can swap the screens over now. There we go. We're about to plug this thing in and start testing. We only have one light to go. Come on. I have soldered one of these holes shut. You see here? The issue is when I was doing my soldering, I put a bit of solder got into here, and now I can't get the other component in. What a bummer. I can melt it just when I get this other. There we go, okay. So I had to melt it and push it through at the same time. It's not ideal. Try to avoid getting solder onto your circuit until you need it. Okay. Last part is just a regular old power terminal. This one's going to be difficult for me to. I'm going to tape this one down just so I can get it in place. Alright. Cool. That should be all my individual parts. Let's plug this thing up to a power supply and see what happens. Now, we've already seen this circuit before, so we can already expect. We already know what to expect. We know to expect some sort of a flashing light. So let's get a negative over here and positive over here. Oops. And let's give us some power. Oh, there we go. So, good news. We didn't ruin the circuit. Nothing bad happened. Oh, are you serious? That's where my screwdriver is. Okay. So we can test this thing over here as we turn this. As we turn this, the lights decrease, and then as we Clockwise, the lights flash faster. That's the fastest we can spin it, but like, so you can clearly see this circuit all works, and look at the size difference of this circuit. So you can see here there's clear differences with the size of the components. Allows you to get, and this is still small, but you can still go much smaller. You can still, like, you could fit this entire circuit probably onto a component the size of one of these individual chips, but it would be almost impossible for a human to solder that, or definitely impossible with a soldering iron. You'd need like the air gun. So we can already see here if half the circuit is surface mount devices, we can really greatly decrease the size of the circuit in general. It's also cheaper because every time you have to drill a hole in these individual circuits, it costs that costs more money because it's a new tool bit. The components are smaller. We noticed this particular circuit didn't actually need the jumper cables, so that's a difference. It also didn't need a larger capacitor. Not sure why. Maybe because there's less power, less current going through it. Actually, no. Sorry, this used 2 capacitors, but they're both electrolytic capacitors. This system ran off smaller capacitors. This capacitor over here on this side of the circuit does relate to. Where's my zoom? No, my focus. This capacitor over here does relate to the 555 timer. So, and the 555 timer is a combination of these resistors and these capacitors is what's affecting the frequency of the 555 timer. So that's why we can't directly relate it to the size of this we can't directly relate it to this capacitor size on this one because it's a combination between this capacitor and these resistors over here. So they're not directly related. Alright, that's good. Now I can clean this up. And there is my example for how to use a surface mount soldering. So now you can go do your own one. That was less than 1 hour and 13 minutes. Good going. Bye. See you next time.